After doing this much of work, go to Analyze and click on Run Analysis and save it. Now click on View Output File and click on Done. From here you can see other things that you already know. Now I am interested in this results option. So click on results and click on concrete design. Here you can see all the inputs and the outputs. FC main, FI main, FE sec, design beam 5 to 8. So beam number 5. And if you click on this and if you press shift plus B, you will get the beam numbers. Okay, so this beam is that beam number 5, which is over here, which is displayed over here. So you can see that design of beam number 5. The length is 6 meters, size is 100 by 150 mm, cover is 25 mm. Section fails while designing section. Which means that this section has failed. And if you see the other sections as well, okay, go to results, concrete design, you can see that almost all of our sections have failed. This is because we defined a small sections and applied huge loads. So no need to worry. Now what we have to do is that we have to define new sections or edit the older ones. So what we will do, we go to the general tab and after that go to the property tab that we are already in and click on this option, that is all these beams. Okay, and click on edit. The depth we will use here is 0.40 meters. Okay, 40 by 0.35. Let me use this section and click on change. Structure as a result of this post-processing results will no longer be available. So do you want to delete all the results files? Click on yes and click on close. Similarly, let us edit the columns as well. Click on edit and let us give the columns as 0.5 by 0.5. And I'm just taking the higher value so that I don't have to come here again and change the size. So click on change and click on close. So now again, let us go to analyze and click on run analysis. So let's save it. So 0 errors and 0 warnings. So 0 error option is very important. If you have got any error, you cannot go further. Let us select view output file option and click on done and click on results and click on concrete design. Now here you can see that beam number 5, length is 6 meters, size is 350 by 400 mm, cover is 25 mm. So summary of the reinforcement has been given. Top reinforcement at 0 meter, which means that at the origin this much value, and 1500 we don't want. At 3000 it's 0 square mm, and at 4500 mm it's 0 square mm, and at the other end of this span it's 444 square mm, which means that this beam has got reinforcement at the top at the edge only. So we have to provide the extra bar, and at the bottom reinforcement we got at the mid portion only. This is how you see the reinforcement values of the beams. While doing the building, we will see how you can detail these reinforcement bar into number of bars and the diameter of the bar. Similarly, you got the reinforcement for the other beams as well. And if I keep on going down, we got design of the column as well. column number 1, design results. Okay, required steel area, required concrete area, and it has also detailed as well. Provide 12 dia bars. Though StartPro can give you detailing also, however, I suggest you not to use the detailing given by this StartPro, because detailing is not an easy task. You have to use your mind. You have to see the condition of the beam, the nearby beams, the columns, the floor height, everything. You have to check. On the basis of that, you have to detail your structural members. Detailing is not something that can be done by a program, but at least not the programs that have been developed currently. For detailing, you have to use your own engineering skills. And if I go down and down and down, you can see the total quantity of this steel that will be used in this building. That is 333770 kg of steel. And the total volume of the concrete is 7.10 cubic meter. This is how you can find the total quantity of concrete as well as the total quantity of the rebar. You can find the quantity of the individual rebar as well, but this is just the approximation. Please use your own skills to get the quantity of steel in your structure. Now let us go to the post-processing option. After that, click on OK. Make sure that all the options are here and click on OK. Let us maximize this window. First, we will see the reaction values. For that, you can just click on reactions over here. Or what you can do, you can go to results and click on view value. And from here, click on reactions. And what reactions you want for the loads. I want global X and global Y. And for bending, I want global RZ. And click on annotate. You can see the reaction values in the X and Y direction and movement in the Z direction. Click on close. Again, go to results. Click on view value and click on beam results. Let us see the displacement first. Click on maximum results and click on annotate. In order to annotate displacement, you must have displacement diagram on. Please switch on the displacement diagram. So we have to switch on the displacement diagram. Click on OK. For that, left click on this option over here. Deflection, click here. You can see the maximum deflection in each beam and the column. And after that, select maximum results and click on annotate. Press Ctrl and scroll your middle mouse button in the clockwise direction. You can see the deflections. You can see the deflections in the beams and the columns. So this is a highly exaggerated view. Now let us see the bendings. For that, we have to first turn on the bending moment diagram option. To do this, click on MZ option that is available here. Left click on it. And after that, click on bending at maximum position and uncheck this maximum results and click on annotate. Okay. Unselect this option, deflection. You can see the maximum bending moment. Let us unsee these reactions. Go to reactions and just uncheck them and click on annotate. And again, let us go to the beam results and hold Control or press Control, and after that use middle mouse button to scale the movement values. You can see how the movement changes in the columns and how the movement changes in the beams. Let us see the front view. Okay, so this is much more similar like a 2D frame. You can see that the movement is maximum at the support and also at the beam column joint. It is the maximum value. That is why beam column joint is considered as a very critical zone. Okay, you can see how high the movement is at this position. Similarly, let us see the maximum shear force. So uncheck this and check this one. and click on annotate. Okay, I have to turn on this one, FY. So press Ctrl and scroll middle mouse button to see the shear values. You can see the shear force values in the beams and the columns. So let us see the isometric view. You can see how the shear force is constant in the columns and how it changes in the beams. At this position, shear force is almost zero, and at the ends the shear force is maximum. Due to this reason, we place the stirrups closer at the ends of the beam and farther at the middle position, because the shear force is minimum at this position. Now let us animate our structure. Click on animation and let us animate the deflection and click on OK. You can see the animated deflection of our structure. So this is how you model your 3D frame, apply the load and design it. Let us open a new project, and as I've already told you many times, please make the configuration as per your requirement. We will open a new project, so click on new project and here click on space option, and let us name this structure as a structure wizard. In this video, we will see what a structure wizard is and how we can use it to model our structures. After naming the file, choose the location where you want to save this file. Choose the units. I have chosen the length unit as the meter and the force unit as the kilonewton. After that, click on next. Here choose add beam. Add beam option allows you to define nodes and the members to draw your structure. From here also you can start the structure wizard, but I'll show you how to open the structure wizard from the main window itself. Okay, after doing this much of work, click on finish. And this window opens. Let us close this snap node beam option. To open the structure wizard, we have to go to the geometry menu. Let us go to the geometry menu. Click on geometry option here, left click, and after that just go down. At the bottom portion you will see run structure wizard option. Left click on it. Here you can see that different models of the truss are available that you can use in your structure. First we will see the frame models. For that, click on this drop down menu over here, model type, and from here choose the frame models. Here you can see different templates of the frame models. First one is the bay frame. We'll see these other options later. Let us first see the bay frame and double click on it, and over here this dialog box opens. Model name is bay frame and the length, height and width is given. Also over here you can see number of bays along the length, number of bays along the height, number of bays along the width. So what are these? I'll explain to you. Let me just cancel this for now and minimize this window and open my sketchbook. Okay, here you can see that we got, suppose, a building. Okay, and this is the height of the building and this is the length, and let me draw another portion, and this is another column, and this is over here is another column, and this is the ground level. Okay, and suppose that this is your x direction and this is your y direction and this is your z direction, and so this is our first floor slab, this is the second floor slab, this is the third floor slab. Similarly we got columns in the z direction as well. If I draw it, look like this. Okay, this is our building, and we got column here as well and another column. Let us suppose we got two columns only. If I have to draw the plan of this structure, then you can see that This is the first column, second column, third column, fourth column in the X direction, and in the Z direction I got 1, 2 and 3 grids. Okay, so one grid, this is already available. Second grid I'm drawing here, second grid is this, and third grid is this one. This is the plan of this building. This is your X direction, this is your Z direction. Okay, and this over here is the Y direction. The length option that you saw in the Start Pro is from here to here in the X direction. So this is the length in the X direction, and this is the length in the Z direction, and this over here, the height of your building, is the length in the Y direction. Okay, and number of bays means how many bays you want. This is one bay, this is another bay, this is another bay. So we got 3 bays here in the X direction, and here also in the Z direction, how many bays we got? We got 1, 2 bays. And in the Y direction, how many bays we got? We got 1, 2, 3 and 4 bays. So in this way, how your structure is and how you want to define your structure, you can define the bays. Now we will define a structure where the length in the X direction will be, okay, so length in the X direction, it will be 16 meter, and in the Z direction it will be 16 meters. Number of bays, if I got a number of bays as 4, then length of each bay will be 16 divided by 4, that is 4. So length of each bay will be 4 meter, 4 meter, 4 meter and 4 meter. We got 4 bays and total length is 16. Similarly in the Z also we will define 4 bays, and in the Y axis what we'll do, we'll define total height as 20 meters. Okay, let's do as 21 meter, and number of bays will be 7, so that height of each bay is 3 meters. H is 3 meter of each floor. Now let us do that, and let us go to the Start Pro and open our structure wizard as we did earlier, and here a bay frame, again double click on it. The length in the X direction is 16 meters, and the height means the length in the Y direction, which is 21 meter, and width, that is the length in the Z direction, is also 16 meter. Just to differentiate what is the length and what is the width, let us take width as 20 meter, and let us take number of bays as 5 number of bays, so that each bay is of 4 meters, and number of bays along the height is 7, so that each floor is of 3 meters height. And click on apply. Here you can see our structure has been defined, and if we see here, then you can see that along the Z axis we got 1, 2, 3, 4 and 5 bays, which means that the width that the structure wizard talks about is the length along the Z axis. Similarly we got length along the X axis, that is here. So this is along the X axis, and it has got 1, 2, 3 and 4 bays, and along the Y axis we got 7 bays. Now we have just defined this template of the frame. Now we have to put it in our modeling window. For that, what you have to do, go to edit and click on add paste model in Start Pro. Left click on it. Here it says, would you like to transfer merge this prototype into Start Pro? You have to press yes. As we define the frame had got the origin, and here also we know that this structure window has also got the origin. So here it asks you where you want to put the origin of the template we just defined, where you want to put that. So if you put x is equal to 0, y is equal to 0, z is equal to 0, means that the frame that we defined just now, the origin of that frame and the origin of our modeling window will coincide. They will be placed at the same position. And right now we don't have any origin because we haven't defined any node, so it won't matter. Just click on OK, and here you can see that we got our frame placed in our modeling window. If you select the node cursor, so let us select the node cursor, and if you double click on this node over here, so double click on this, okay, save it, double click on this node. Here it says x is 0, y is 0 and z is also 0, which means that this is the origin of this frame as well as the origin of our modeling window, and click on close. This is how you can use structure wizard in order to define a frame. Now after you have defined the frame, all you have to do is go to general option and define the property of the beam and frame, define the supports, apply the loads, and move further into the structural design of this frame. In normal practice, the buildings are not this regular. Suppose that if a bay is of 5 meters in the X direction, the next bay will be of 4 meters or 2 meters if it is a corridor, and the next bay is of 6 meters. Real life buildings are not regular. That is why I do not prefer to use this structure wizard option. I always prefer to model my structure by defining the nodes manually from here. Moving on, let us see other options that are available in the structure wizard. Just click on this window. After that, press Ctrl A and delete whatever you have defined, and click on OK. It will delete everything that you have defined so far, and click on yes. Now let us see other options. Go to geometry again and click on run structure wizard option that is available at the bottom, and from here model type, select the frame models. The bay frame that you just saw here, you can see that the bottom columns are not connected, the lowermost columns are not connected to each other. In the grid frame, the lowermost columns are connected, that you can see. If you just left click on it and just click on apply, you can see that the lowermost columns are also connected. Okay, and if you want this type of frame, you can use this option. Next one is the floor grid option, and if you left click on it and click on apply, you can see you got only the floor. In these two cases we had the entire frame, but in the floor grid option we just have a single floor. Similarly, you can define the continuous beam as well, or the cylindrical frame, and if you double click on the cylindrical frame, length, okay, let's take 20. What is the radius of the cylinder? You want 5, and angle, how much you want. Right now angle is 360 degree, and number of base length, let us keep default values right now. You can practice with other values and see what happens if you use different values. Click on apply. Here you can see that you got a full cylinder. Okay, and here you can see number of base, what it means. So this is the Z axis, this is the X axis, and this over here is the Y axis. So it means that it is like this. This structure is like this. Suppose that you got a frame and you want a dome over the frame, something like this. If you want any structure, okay, something like this, let me draw it. Okay, so suppose that this is your frame, this is your frame, okay, this is your frame, and you want to have a dome like this on the roof of it. This dome expands throughout, okay, and this is the dome. This is the dome you want on the top of your frame. In that case, you can use this. How? I'll show you. Here, just select the cylindrical frame and give the angle as 180 degree, and choose the number of bays along the length and number of bays along the periphery as per your requirement, and click on apply. You can see that you got a half dome like structure. Okay, similarly you can see the circular beam and reverse cylindrical frame also. Try to play around these options, what are they and how they can be useful to you.